Okay, we're going to do another example because you need it. Yes, you do. Maybe you think you get it. Watch the video. Make sure that you get it because you don't want to lose points when you don't have to. Okay, here we go. I am now flipped over to Ionic equation set, problem set 2. I will give you the answers to these. Those are going to be uploaded for you, so they'll be there in essential documents. Go ahead and look at them. But I'm going to do 2. I already wrote it out here for you to save some time. 2F. 2F. Okay, it's done in words. Save some time. I hope at this point you would be able to do this on your own. Symbols in for the words. We have to make sure it's balanced, though. I didn't check for balancing. So let's see if it's balanced. Okay, check the metals. Calcium 1, calcium 1. That's good. Lithium 1, lithium 2, lithium 1. Not good. Put a 2 here in front of that lithium to balance that. Check your polyatomic ion groups. Sulfate, sulfate. Good. Last but not least, bromine 2, bromine 2, we're good. Okay, that is now balanced. Let's write the ionic equation. So the ionic equation says split everything up. So to split up, break them. Calcium plus bromine. Now I'm going to put the 2 bromine right here. I know there are 2 bromines, so I'm going to go ahead and put that 2 bromine right there right now. You don't have to, you can go back and do it later, but get her done. Plus 2 lithiums plus sulfate makes 2 lithiums plus, we're just separating these compounds, 2 bromines though, be careful because that is a coefficient that does count for the bromine, and calcium and a sulfate. All right, we've got everything split up. I made sure I had the same amount, 2 of those, 2 of those, 2 of those, and 2 of those. We got a nice balanced reaction, but we have to show the charges is an ionic equation, and those charges have to balance, and they will. You can check the charge if you want to add them all up, positives and negatives, they'll cancel. But we get a calcium with a 2 positive, a bromine with a negative, a lithium with a positive, sulfate's a 2 negative. So lithium positive 1, negative 1, positive 2, negative 2. All right, so I put all the charges in, and we are done. Okay, so now here's what I did. What I just did is I just wrote everything down and separated everything. All right, that's what I'm going to do. Now, I would probably want to use a pencil on this in case I have to do the following. Now I'm going to check to see if anything in this compound on the right, you're only going to check the products, are any of these products insoluble? If they are, I'm going to have to make an adjustment. But if they're not, if both of these products are soluble, both dissolved in the water, then that's exactly what I would have done. It's good. So if everything is soluble, we're just going to leave it the way it is. All right, let's check that. So look at your handout. Go and check it. Look at it. Now, of course, on here, they take a sheet and they put an arrow down for one of them. They tell you. I won't tell you. I will not tell you. You're going to have to use the chart. Use the chart. Lithium, alkali metal, always soluble. So yes, it would split apart. Sulfate, usually soluble compounds. However, look at the chart. Calcium sulfate is not soluble. That's an insoluble salt. That means that it would not stay separated like this. So what I'm going to have to do is simply that. And that was pretty easy for me because I can just erase the marker. I know that you can't do that, so sorry. Forgot about that. You can't be finger erasing. Sorry. So this would not separate. So I took the plus out and took the charges away. It would stay as a compound. It's insoluble. It would not separate. Okay? All right. So there's my ionic equation showing the ions, the breakup of everything which is soluble, keep together the thing which is insoluble. Now, if calcium sulfate were soluble, it would have been fine to leave it just the way it was. If calcium sulfate were soluble, and both of these are soluble, I would have no net ionic equation because you would not have an insoluble salt. But we do. We do have a Knights of Ni equation. Yes, we do. Because a Knights of Ni equation, net ionic equation, shows the things that make the insoluble salt. So that is an insoluble salt. Let's show what made it. Okay, calcium made it. Bring that calcium right down. Just bring it down. The sulfate made it. Bring that down. Put an arrow and put the insoluble salt down. And that is your net ionic equation for that example. What are the spectator ions? Everybody else that didn't get involved in making the insoluble. That would be the bromine and the lithium. You see, they're identical on both sides. They're identical. They didn't change. They spectated and watched and didn't do anything. So those are your spectator ions. The calcium and the sulfate got together and formed calcium sulfate. And we show that in the net ionic equation. And that is another example of how to do an ionic equation. All right, I am done a couple of examples of these, 3 actually. 1 did not have a net ionic equation and 2 did. And I hope that you go, well, they're not too bad. I mean, I know a lot of times students will say they're not too bad if I'm doing them and I'm explaining them. And they go, oh, okay. When you go to do them on your own, a lot of times that becomes a different story. Like you're doing this and like a week from now you go and have to try it again because the test's coming up and you go, oh man, I can't do this. Well, rewatch the video. That's what's good about that. You go watch me over and over again, okay? I'm here for you, okay? All right, that wraps up this week's material. Yeah, that's it. That's all for the weekend. You people have a good weekend.